Good morning. Happy Wednesday. First of all, I just want to start off by saying how much I miss each one of you and hope that you and your family are all staying healthy. And I truly hope we'll be back in the classroom soon so I can hear all about the good news you all have to share. So before spring break, we left off and we were solving quadratic functions and equations. We learned different methods. We learned the factoring form. We learned how to solve with the square root theorem. We learned how to solve completing the square. We learned about the quadratic formula. So today we're going to start graphing quadratic functions. There are 3 different forms of a quadratic function. Today we're only going to look at the first form, which is standard form, and then we'll continue on to look at other forms throughout this unit. So if you were able to print off the guided notes for lesson 7.5, you should have those in front of you because we will be using those for the remainder of this audio session. The objective says I can graph quadratic functions in standard form, vertex form, and factored form. The graph of a quadratic function is called a parabola. That's the shape that is created. There are 3 forms of a quadratic equation. The first one is f of x equals ax squared plus bx plus c. That is standard form. That's what we are familiar with. That's what we had to have each function or equation in that form before we could complete the square, before we could factor, before we could use the quadratic formula. Okay, so we're familiar with standard form. Remember, the a, the b, and c are all numbers or coefficients that are in front of those variables x. The next one, f of x equals a times x minus h squared plus k, that's called vertex form. We'll get to that form, but not today. We'll only focus on standard. And then the third form, f of x equals a times x minus p times x minus q, is called factored form. And this one's not really as common of a form. You'll see mostly standard form and vertex form. So we're going to look at a couple things, some things to fill in before we actually start graphing. If a, remember in this case our a is right here, what's in front of our x squared term, is positive, the graph opens up. When it says the graph, it's talking about the parabola. You're going to have a parabola that opens up. If a, which is in front of the x squared term, is negative, the graph opens down and your parabola is going to look like this. All quadratic equations have a vertex, which is the turning point of the graph. So on our green parabola here, the vertex is the lowest point of that parabola. That's our vertex. Let me write that a little more clear. In the parabola that opens down, our vertex is the highest point. So in this one, that is our vertex. Quadratic graphs are symmetrical across the axis of symmetry. Symmetrical means they look exactly the same on both sides. You're probably familiar with symmetry from art or from different math classes. I like to abbreviate this as A of S, just so there's not as much writing to do. The axis of symmetry runs through the vertex. So if your axis of symmetry when we graph does not go through the vertex, you've done something wrong. The formula to find the vertex, so this is the formula to find the vertex, is, I'm going to do it in a different color, negative b over 2a. And we're familiar with b and a from standard form. Remember, a comes from your x squared and b comes from your x term. Okay, so that's what we're going to be doing, just plugging in those numbers. A quadratic function crosses the y-axis always. Always. The y-intercept always has an x value of 0. Because the x value is 0, it's going to be hitting the y somewhere else. So it's like your y-intercept. For a parabola, the y-intercept will be the point 0, c. Well, where is c coming from? C is coming from our standard form. If we look back up at f of x equals ax squared plus bx plus c, whatever that value of c is, that's where it's hitting. A quadratic function crosses or touches the x-axis 0 times, meaning not at all, 1 time, or 2 times. Okay, so what would that look like? So in a rough sketch here, a parabola or a quadratic function that is a parabola that does not touch the x-axis could look something like this. It's not hitting the x-axis. Remember, that's x. A parabola that touches the x-axis 1 time would be the vertex of that parabola, that highest point. A parabola that touches the x-axis 2 times could look something like this. And it's touching x there, and it's touching x there. So that's what that means. Okay, we're going to move on now, and let's look at this parabola. In this graph, let's identify the vertex. This vertex is the lowest point of the parabola. The vertex is right here, this green dot I'm drawing. How do we identify it? Well, we start from the origin, and we move left to -1. That's going to be the x value. Then we come down, and when we go down 1, 2, 3, 4 to -4. The vertex is the ordered pair -1, -4. The axis of symmetry is always the x coordinate of your vertex. So if I look at my vertex, -1, -4, the axis of symmetry, it's an equation, x equals -1. So you don't want to just write -1, you want to write x equals -1. In a moment, when we actually create our graphs, we will take and we will indicate our axis of symmetry by drawing a dotted line through x equals 1, and we will identify it like that. That is splitting the x equals -1. It is splitting our parabola symmetrically. Okay, the y-intercept is always 0c. In this case, we aren't given the actual function, the quadratic function, so we're just going to find where it's hitting the y-axis. 1, 2, 3. At 0, -3. 3 down from 0. There are 2 x-intercepts. It's crossing the x-axis here, and it's crossing the x-axis there. So let's do the one to the right first. That would be 1 on the x, 0 on the y. We'll do the other one, 1, 2, -3. So this is going to be -3, 0. Okay? So far, so good. Okay. Now we're ready to graph in standard form. To graph in standard form, we have our given quadratic function. F of x equals a of x squared plus b of x plus c. And they want us to graph the function 4x squared minus 8x plus 1. I want you to identify a, b, and c. A is 4, b is 8. Not 8, but -8. And c is 1. Okay? How did I get that? A comes what's in front of your x squared term, B comes with what's in front of your x term, and C is your constant term. To find the axis of symmetry, you do x equals negative b over 2a. Well, our b is negative 8, so the negative or opposite of negative 8 is 8 times 2 divided by 2 over a, which is 4. So this becomes 8 over 8, and that equals 1. Okay? So we take that axis of symmetry, and I guess we, let's go. To find the vertex, plug this number 1 back into the equation. So the equation was up here, 4x squared minus 8x plus 1. So we're going to find the f of 1. 4 times 1 squared minus 8 times 1 plus 1. We square 1 first and then multiply it by 4. So 1 squared is 1. So this becomes 1 times 4 minus 8 times 1, which is 8, plus 1. So this equals 4 minus 8 plus 1. 4 minus 8 is negative 4. Negative 4 plus 1 is negative 3. We have created our vertex now. Our vertex is the ordered pair. 1 from the axis of symmetry and negative 3 from plugging that 1 in. These create vertex. Okay? Let's go and fill a little bit more into this box. We already know A, B, and C. We had 4, negative 8, and 1. We know the parabola will open up or down by looking at the value of A. A is a positive 4. Since it's positive, it opens up. That means the parabola, if it's opening up, the vertex is a minimum point. If you go back up here, let's look back for a minute. If it's opening up, the vertex is at the bottom, that's a minimum point. The vertex is at the top when it opens down, that's a maximum point. Okay, so we can now go back. And the y-intercept is always 0c. C is 1, okay? From there, we're going to create one more point, and we're going to do that after we graph what we know, okay? So let's graph what we know. Let's start with the axis of symmetry, which we have not filled in. We found that was x equals 1. With your ID or a straight edge, you draw for an axis of symmetry a dotted line through there, a dotted line. Don't make it a solid. This is the axis of symmetry, x equals 1. Okay? From there, I'm going to do my y-intercept. My vertex. My vertex should be right on that axis of symmetry. My vertex is 1, negative 3. See how it's on that same line? That's my vertex. Then from there, I'm going to do my y-intercept. My y-intercept is 0 on the x, 1 on the y. Okay, how do we get our other point? This is the part where you really have to pay attention. If you notice that when I look at my axis of symmetry, if I go 1 to the left, that's my y-intercept. For something to be symmetric, it means I can also go 1 to the right and put a point. When I go 1 to the right, I identify that point as 2, 1. It makes that symmetric. Okay? So that's my other point. When you draw your parabola, you're going to just draw it freehand. Okay? Because you can't really use a ruler. Let me do a better job of that. You at least want to try to come through the points that you have here and bring it up. And remember, that parabola is going on and on in both directions. So here's your vertex. You can label it as 1, negative 3. You can label your y-intercept as 0, 1. Okay, all you need is 3.